Alright, this is Quiz 2 Study Guide. Please pay real close attention right now because I have to cover something that you're not going to see on the study guide, but you're going to see it tomorrow in your quiz. And here's what I mean by that. On your quiz tomorrow, first period and fifth period's quiz is multiple choice. You will have multiple choice answers that look like this. You may have an answer choice that is 3 radical 3 and another one that is 27 and then a 2 radical 35 and a 140. If you work the problem out and your answer is not B and it's not D, 3 radical 3 means 3 times the square root of 3. And in your calculator, that operation is you push 3 times and then you push 3 and the square root button and you hit equals. And 3 times the square root of 3 is equal to 5.2. So answer A is equivalent to 5.2. Understand? 2 radical 35 means 2 times the square root of 35. And in your calculator, again, that is 2 times, then you type 35, you push the square root button and hit equals. And that's 11.8. So answer C is equivalent to 11.8. Some of the questions will have all radicals as answers. Some will have just a couple. And you'll have to convert it from a radical to a decimal. Everybody understand that? Okay. So then number 1 on your study guide. Problems number 1 and 2 says to find the geometric mean of the pair of numbers. The geometric mean of 275 and 11 is equal to the square root of 275 times 11. So in your calculator, you multiply 275 times 11, push equals, and then hit the square root button. And that's 55. And then number 2 is 36 and 4. So the geometric mean of 36 and 4. 36 times 4. And square root button, so that's 12. Alright, number 3. What are the values of A and B? Alright, again, you've got an altitude. You've got a altitude drawn to the hypotenuse of a right triangle, which means that A is going to be equal to the square root of 32 times 2. So A is going to be equal to the square root of 64, and that's equal to 8. We said that B will be equal to, B is going to be equal to the square root of this distance right here, which is 34, times this distance right here, which is 2. So that's the square root of 68. which is is 8.2. Number 4. Number 4 asks you to find the length of the altitude drawn to the hypotenuse. This dimension right here, this segment, this vertical segment, is the altitude drawn to the hypotenuse. That's what you're looking for here. I'm just going to call it H. H is equal to the square root of the geometric mean of the two pieces it creates. So that's going to be 7 times 21. So that's the square root of 147, which is equal to 12.1. Number 5 is another right triangle problem. We've got the park, the library, home, and the football field. Alright, question A says, how far is the library from the park? Library from the park, that's going to be this dimension right here. So library to park is going to be equal to the square root of 2 times 5. So that's the square root of 10, which is equal to 3.2. The second distance that they ask for, question B, how far is the park from the football field? Park to the football field. We're going to call that question B. That's going to be equal to the hypotenuse of this big right triangle, which is 2 plus 5, which is 7. Alright? It's going to be the geometric mean of 7 times 5, which is this closest piece to the segment we're trying to find. So B is going to be equal to the square root of 7 times 5, which is the square root of 35, which is 5.9. And those are both in miles. Number 6 is a Pythagorean Theorem problem. You're given the hypotenuse as 18, one leg is 11, and you need to find this missing leg. So if you label the sides of this right triangle, the sides adjacent to the 90-degree angle are always A and B. The hypotenuse is always side C, and you know that A squared plus B squared equals C squared for every right triangle. So now you can substitute 11 squared plus B squared equals 18 squared. So that's 121 plus B squared equals 324. Subtract 121 from each side, and B squared equals 203. You can now find the square root of both sides, and your b will be equal to 14.2. Number 7. A grid shows positions of a subway stop and your house. The subway stop is at negative 5, 2. Your house is at negative 9, 9. So you've got a coordinate plane here. The subway stop is at negative 5, 2. Your house is at negative 9, 9. There's your house. Here's the subway stop. What is the distance to the nearest unit between your house and the subway stop? You're trying to find this distance right here. Okay? So, if you take this diagonal and turn it into the hypotenuse of a right triangle, we're going to use the Pythagorean Theorem to find its distance. So this distance right here, this vertical distance, is the difference between 9 and 2, which is 7. This horizontal distance, the length of this horizontal leg of this triangle, is the difference between negative 9 and negative 5, which is 4. So now you've got your A, your B, and your C for a right triangle. So 7 squared plus 4 squared equals C squared. So 49 plus 16 equals C squared. $65 equals C squared. And if you find the square root of both sides of this, 8.1 is equal to C. And the question was to the nearest unit, the distance. So that's going to be 8 units. Alright, write this down in your notes because I don't think you guys got this yesterday. Just keep it right where it's at, right where you're going right now. Alright, you can just use these notes tomorrow on your quiz. We're going to say this right here. If A squared plus B squared equals C squared, it's a right triangle. If your A squared plus your B squared is greater than your C squared. If your A squared plus your B squared is greater than your C squared, then it's an acute triangle. And if A squared plus B squared is less than C squared, it's an obtuse triangle. Real important, write this down. This is when the two shortest sides are labeled A and B. So we're going to use this rule for the next three problems. Number 8 says a triangle has sides of 6, 8, 10. Is it a right triangle? Well, it has sides of 6, 8, and 10. So we label the two shortest sides A and B. That makes the third side C. So does 6 squared plus 8 squared equal 10 squared? That's the question they're asking. Does 36 plus 64 equal 100? Yes, it does. So is the triangle a right triangle? Yes, it is.
What happens if they have the same number? Like if they come out to equal the same?
They do. They both equal 100, so it's a right triangle. Right? 36 plus 64 is 100. 100 equals 100.
Yeah.
So yes, it's a right triangle. Number 9 asks you to, it tells you a triangle has lengths of 14, 48, and 50. Now the question is, classify it as acute, obtuse, or right. Well, we're going to do the math on this one. We're going to label these A, B, and C. The two smallest are A and B. And we're going to determine what 14 squared plus 48 squared, how it compares to 50 squared. Now, in your calculator, you can push 14x squared plus 48x squared and push equals, and it will square these and combine them. So that's 2,500. And 50 squared is also 2,500. So these two are equal to each other. If your A squared plus your B squared equals your C squared, it's a right triangle. Number 10 is the same question. A triangle has side lengths 28, 4, and 31. Classify it as acute, obtuse, or right. So again, the two smallest sides are always labeled A and B. The longest side is C. So we're going to take 28 squared plus 4 squared, and we're going to compare it to 31 squared. So the left side of this equation is equal to 800, and 31 squared is equal to 961. So in this case, your A squared plus your B squared is less than your C squared. So if you go back to the rules we just wrote, if A squared plus B squared is less than C squared, it's obtuse. So number 10, this triangle is obtuse. Number 11. Find the value of x, y, and z. The triangle is not drawn to scale. The x, y, and z are missing on your copies, so the x goes right here at the altitude drawn to the hypotenuse. The y is the left leg of this triangle, and the z is the right leg of this triangle. Alright, so this x is equal to the geometric mean of 5 and 17. X is equal to the square root of 5 times 17. 9.2. Now for y and z, we're going to add this dimension right here, which is the sum of 5 and 17, which is 22. Y is equal to the geometric mean of this entire piece and this piece closest to it. So y is equal to the square root of 22 times 5. So in your calculator, you can push 22 times 5, hit equals, and then the square root button. So 10.5. Side z. Side z is equal to the geometric mean of this entire hypotenuse again and the segment closest to it. So z is equal to the square root of 22 times 17. So again, that's 22 times 17 equals, and square root button, 19.3. Alright, we got 2 problems left. Number 12. What similarity statement can you write relating the 3 triangles in the diagram? We covered this on Tuesday. This big triangle around the outside is a right triangle. Segment MK is an altitude drawn to the hypotenuse. So the big triangle is similar to the 2 triangles inside, which are similar to each other. So we're going to write a similarity statement. We're going to say that triangle. And we're going to label this big triangle around the outside. And the order that we're going to use is right here. We're going to go short side, long side, hypotenuse. Short side goes from J to M. Long side uses the M and goes to L. Hypotenuse goes from L to J, which is your first and last letters in the description. So we labeled the first triangle going short side, long side, hypotenuse. That triangle is similar to triangle. We're going to use this triangle on the left now, and we're going to use, here's its short side, here's its long side, and here's the hypotenuse. So the order of those vertices goes J, K, M. And that triangle is similar to triangle. We're going to use that same order of short side, long side, hypotenuse. M to K is the short side of this last triangle. The long side is K to L. And the hypotenuse goes back to M. So the last description is going to be M, K, L. That is your similarity statement for that problem. Now, if you change the order of the first triangle, you just have to change the order of the other triangles so that all the sides and angles correspond. Does everybody understand that? If you call the second triangle, or I'm sorry, if you call the first triangle, if the first triangle is called MLJ, then the second triangle would have to start with the original first vertex. So the second triangle would have to be called KMJ. And the third triangle would have to be called KLM. Both of those similarity statements, this similarity statement and this similarity statement, they're correct. They both work because the order's changed and everything corresponds. Understand? Okay, number 13 is the same type of problem. It's just one more practice problem. So I'm not going to do that one at this time. I'm going to let you do that one on your own, and the answers are on the bottom of that page. Does anybody have any questions on any of those problems? Okay. That concludes your study guide for quiz number 2.